Hello, my dear children. Today we are going to discuss about the questions in exercise 5.1. Come to the question number 5. In the previous class, we have discussed some questions. Now it's continuation. Question number 5. Is the function f defined by f of x is equal to x if x is less than or equal to 1, f of x is equal to 5 if x is greater than 1. Here f is defined like this. If x is less than or equal to 1, f is defined as f of x is equal to x. If x is greater than 1, f is defined as f of x is equal to 5. Is it continuous at x is equal to 0, at x is equal to 1, at x is equal to 2? In three different points, we have to verify that the given function is continuous function or not. Understood the question, my dear children? Right. First I wrote here given function, given f of x is equal to. I wrote the given function as it is here. Okay, my dear children. Now I am representing the given function graphically on the number line. So here I have drawn number line -1, 0, 1, 2, 3. Here at the point 1, the f of x is defined in two ways, less than 1 and greater than 1. In two different ways f is defined. If x is less than or equal to 1, how the function f is defined? F of x is equal to x. So this is left side part of x is equal to 1. This is the right side part of x is equal to 1. So in these two intervals, I am writing clearly f of x is equal to x. If we take any value in this interval, f of x is taken as x only. If any number in this interval, if you choose any number in this interval, then f of x is equal to 5. Understood this diagram, my dear children? Right. Here totally there are three parts. At x is equal to 0, we have to check the continuity of f. At x is equal to 1, we have to verify the continuity of f. And at x is equal to 2, we have to verify the continuity of f. Okay, my children. Now, we are verifying the continuity of f at x is equal to 0. To check the continuity of f at a particular point, we have to find the limit of the function at that particular point and the function value at that particular point. So we are finding the limit of that function at that particular point, x is equal to 0. So as x tends to 0, limit f of x is equal to, as x tends to 0, limit f of x means here x, because as x tends to 0 means it is less than 1, x is less than 1. That implies if x is less than 1, how the function is defined? F of x is equal to x. That is why in the place of f of x we have taken x only, not 5. Understood this step, my dear children? Right. Now substitution method. We are going to find the limit of this function at x is equal to 0. So put x is equal to 0 here. What do you get here? 0 only. So limit of this function at x is equal to 0 is 0. We have found limit of the function at that particular point. Similarly, we have to find the function value at that particular point. So f of 0. In this function put x is equal to 0. What do you get here? 0. Here also 0. So if you observe, limit of the function at x is equal to 0 and the function value at x is equal to 0, both are equal. Here as x tends to 0, limit f of x is equal to f of 0, both are equal. Then what can you say here? F is continuous at x is equal to 0. Understood, my dear children? Right. Now come to the next part of the question, second part of the question. We have to verify the continuity of f at x is equal to 1. Okay, my dear children? Right. Here at x is equal to 1, the function is defined in two different ways. If x is less than 1, f of x is defined as x. If x is greater than 1, f of x is equal to 5. That is why here we have to find left hand limit of f at x is equal to 1. Similarly, right hand limit of f at x is equal to 1. That is why we are finding here left hand limit and right hand limit. Understood, my dear children? Right. So, left hand limit of f at x is equal to 1. Here we are finding right hand limit of f at x is equal to 1. Symbolically, we write like this: as x tends to 1 minus limit f of x is equal to, as x tends to 1 limit x, because as x tends to 1 minus means x is less than 1. Left side, x is less than 1. Then f is defined as f of x is equal to x. That is why in the place of f of x we have taken x. Understood this step, my dear children? Right. Now we have to find the limit of this function as x tends to 1. So substitution method. In the place of x, substitute 1. So what do you get here? Limit 1 only. So left hand limit of f at x is equal to 1 is 1 only. Now come to right hand limit of f at x is equal to 1. Symbolically we write like this: as x tends to 1 plus limit f of x, that is equal to as x tends to 1 limit 5. Why we are writing here f of x is equal to 5? Because as x tends to 1 plus means x is greater than 1. Greater than 1. Then f is defined as f of x is equal to 5. That is why in the place of f of x we have taken 5. Understood that step, my dear children? Right. Now come to this part. We have to find the limit of that function. Here no x is there, so no substitution. Directly its limit is 5 only. Understood this, my dear children? Right. So here left hand limit is 1 and right hand limit is 5. Are these two numbers equal? Not at all. So here as x tends to 1 minus limit f of x is not equal to as x tends to 1 plus limit f of x. Then what can you say here? F is discontinuous at x is equal to 1, because both limits are not equal. Left hand limit and right hand limit are not equal. Understood this step, my dear children? Right. Now come to the third part of the question. Verifying the continuity of f at x is equal to 2. Here we have to verify the continuity of f at x is equal to 2. So we have to find limit of the function f at x is equal to 2. So as x tends to 2, limit f of x is equal to, as x tends to 2, limit 5. In the place of f of x I wrote here 5, because as x tends to 2 means x is greater than 1. Understood, my dear children? Then f of x is defined as 5. F of x is equal to 5 only. So that is why in the place of f of x I wrote here 5. Understood this step, my dear children? Right. That is equal to, here we have to find the limit of this function as x tends to 2. Here x is not there, so no substitution. Directly the number it is as it is. So the limit of this function is 5 only. Understood this step, my dear children? Right. Now we have to find the function value. Value of that function at x is equal to 2. So f of 2, that is equal to 5, because f of x is equal to 5 as x tends to f of x greater than 1. So f of 2 is also 5. So here by comparing these two, limit and function value both are equal. Therefore here as x tends to 2, limit f of x is equal to f of 2, both are equal. Therefore we can say that f is continuous at x is equal to 2. Understood, my dear children? Right. Now come to the next question, that is question number 7. Find all points of discontinuity of f where f of x is equal to mod x plus 3. If x is less than or equal to minus 3, f of x is equal to minus 2x. If minus 3 less than x less than 3, f of x is equal to 6x plus 2 if x is greater than or equal to 3. If you observe this function, here it is defined in 3 intervals. If x is less than or equal to 3, and between minus 3 and 3, and x is greater than or equal to 3. So at these 2 points, at this point x is equal to minus 3 and at x is equal to 3, just it is enough to verify the discontinuity or continuity of f. At these 2 points are enough to find points of discontinuity. Okay, my children. So come to the solution part. Here I am representing the given function pictorially on the number line. I have taken the number line minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Here at x is equal to minus 3 and at x is equal to 4, 3. I have drawn lines. So this is one interval. The entire number line is divided into 3 intervals: less than minus 3, minus 3 to 3, and greater than 3. Into 3 intervals, the entire number line is divided. So in this interval, f of x is defined as mod x plus 3. This can be written as minus x plus 3 because x is less than minus 3. X is less than minus 3 means x is a negative number. If x is a negative number, what is the value of mod x? Minus x. So that is why instead of mod x, I wrote here minus x plus 3 as it is. Understood this function, my dear children? Right. Come to this interval minus 3 to 3. In this interval, f of x is defined as minus 2x. So I wrote here. And the last interval, third interval, x is greater than or equal to 3. If x is greater than or equal to 3, f of x is defined as 6x plus 2. Understood this picture, my dear children? Right. Now come to the first part of the question. Here we are verifying the of f, continuity of f at x is equal to minus 3. Continuity of f at x is equal to minus 3. Here at x is equal to minus 3, f is defined in two different ways. If x is less than or equal to minus 3, f is defined separately, and if x is greater than minus 3, f of x is defined differently. That is why we are finding here left hand limit of f at x is equal to minus 3 and right hand limit of f at x is equal to minus 3. Understood, my dear children? Right. So as x tends to minus 3 minus limit f of x is equal to, as x tends to minus 3, limit minus x plus 3. In the place of f of x, I wrote here minus x plus 3 because as x tends to minus 3 minus means x is less than minus 3. So x is a negative number. Then f of x is equal to minus x plus 3. That is why I wrote here minus x plus 3 instead of f of x. Understood this step, my dear children? Right. Now we are going to find the limit of this function at x is equal to minus 3 by means of substitution method. So in the place of x we substitute minus 3. So minus of minus 3 plus 3 as it is. Understood this step, my dear children? Right. That is equal to minus of minus 3. What do you get here? Plus 3 plus 3. Now we simplify these two terms. What do you get here? 6. Understood this left hand limit of f at x is equal to minus 3, my dear children? Right. Similarly, we are going to find RHL, means right hand limit of f at x is equal to minus 3. So as x tends to minus 3 plus limit f of x is equal to, as x tends to minus 3, limit minus 2x. In the place of f of x, observe here I wrote minus 2x because as x tends to minus 3 plus means x is greater than minus 3. If x is greater than minus 3, then f of x is defined as minus 2x. That is why in the place of f of x, I wrote here minus 2x. Understood this step, my dear children? Right. Now we are going to find the limit of that function by the means of substitution method. So minus 2 into, in the place of x, substitute minus 3. Then you get this step. Understood this step, my dear children? Right. So minus of minus, what will you get? Plus 2 into 3, 6. So if you observe here, left hand limit is 6 and right hand limit is also 6. So I wrote here the step as x tends to minus 3 minus limit f of x is equal to, as x tends to minus 3 plus limit f of x is equal to 6. Both limits are equal. Now we have to find the function value at x is equal to minus 3. So f of minus 3 is equal to minus of minus 3 plus 3. Understood this step, my dear children? Right. That is equal to, by simplifying these two terms, we get 3 plus 3. What will you get here? 3 plus 3? 6. So if you observe here, all these three values are equal. Left hand limit, right hand limit, and function value at x is equal to minus 3. All these three values are equal. So I wrote here as x tends to minus 3 minus limit f of x is equal to, as x tends to minus 3 plus limit f of x is equal to f of minus 3. Therefore, we can conclude that f is continuous at x is equal to minus 3. Understood, my dear children? Right. Now come to the next part of the question. That is verifying the continuity of f at x is equal to 3, because the function is defined at minus 3 and 3 differently, left hand and right hand side. That is why at x is equal to 3 we are going to verify the continuity of f. Understood, the my dear children? Right. Left hand limit of f at x is equal to 3 and right hand limit of f at x is equal to 3. As x tends to 3 minus limit f of x is equal to, as x tends to 3 limit minus 2x. Instead of f of x, I wrote here minus 2x, because as x tends to 3 minus means x is less than 3. If x is less than 3, then f of x is defined as minus 2x. Okay, my dear children, we have to take this function only. That is why I wrote minus 2x instead of f of x. Understood this step, my dear children? Right. Now we are going to find the limit of this function at x is equal to 3 by the means of substitution method. So minus 2 into, in the place of x, substitute 3. So minus 2 into 3, what do you get here? Minus 6. Understood this step, my dear children? Right. Now come to the right hand limit of f at x is equal to 3. As x tends to 3 plus limit f of x is equal to, as x tends to 3 limit 6x plus 2. Observe here, my dear children. Observe this step, my dear children. Instead of f of x, I wrote here 6x plus 2, because as x tends to 3 plus means x is greater than 3. Then f of x is defined as 6x plus 2. That is why I wrote here 6x plus 2 instead of f of x. Understood this step, my dear children? Right. Now we are going to find the limit of that function at x is equal to 3 by the means of substitution method. So 6 into, in the place of x, write 3 plus 2. Okay, my dear children? Understood this step, my dear children? Right. 6 into 3, what will you get here? 18 plus 2 as it is. Understood this step, my dear children? Right. 18 plus 2, what will you get here? 20. Now compare these two limits. Left hand limit is minus 6 and right hand limit is 20. Are these two numbers equal? No, not at all. They are not equal numbers. Therefore, here as x tends to 3 minus limit f of x is not equal to as x tends to 3 plus limit f of x. Both limits are not equal. Therefore, we can say that f is discontinuous at x is equal to 3. Here no need to find the function value at x is equal to 3, because here Here itself left hand limit and right hand limit are not equal. So no need to find function value at x is equal to 3 here. Understood, my dear children? Right.